let's take a look at removing the distributor and its cap for gaining access to that hose clamp for removal. So the first thing is you're going to want to remove the distributor cap. You don't want to remove the distributor with the cap because that's going to lead you to disconnecting the wire. You want to do the least amount of disconnection on the ignition system because it could lead to broken wires and broken parts. But if you do happen to be lucky to do so, when you are attaching these electrical components back together, it's very important that you use some dielectric grease. Now that we have the distributor cap removed, you're going to need to remove this plug for the distributor and also this plug here, which is going to be difficult, this one here with the 2-pin, because it has this special connector, see here, and it has this green slide that you have to slide it in and then be able to pull the plug apart. You also have to be careful that you don't break the fastener section of the plastic on the plug. If you do so, you're going to have to secure it back to that location. Never leave the harness dangling, because it could damage the wire and it could lead to shortage. Now, the last part for removing the distributor is we want to make sure we put a mark, like you see here, where it's pointing at, and that mark has to be referenced with a mark down in there. You see that? So, I don't mean to make it confusing, but the two marks I'm looking for are the two that's closest together. That mark on the outside is where the paint fell, so that's an error. Now, once you have these two-part reference, you're going to need to remove that 12mm bolt that holds down the distributor inside the cylinder head, because this distributor rides off of this left side camshaft. To remove that bolt, you're going to need a 12 socket, something like this. You want a short one, 6.3/8 drive with an extension that has a wobble. You see that wobble on the end? So you don't damage that TPS sensor. If you try to go down there with a straight extension without that wobble, you're going to likely brace against that TPS when you're making that turn. You're going to damage the TPS. So you want that wobble and you want that short socket right there. Fortunately, it did not fall down into the engine valley most of the time. You're always going to run into error and bad luck when removing this stuff. So you have to be patient and also look at these videos, because they're going to give you a heads up on what you're dealing with. Now we're going to just pull this distributor out of here, because it's not that important that we keep the alignment in position for removal. So the reason it's a little difficult to remove is because it has a slanted gear on it, something like a worm gear that rides against the camshaft. So this is going to require 2 hands. With both hands, I was able to remove the distributor, but I just laid it back in to show you. So the first thing you want to look at is this gear. You want to make sure it's perfect. There is no grind, there's no kind of disform to it, because this will affect the timing of the engine if this gear has any wear and tear or abnormalities. So this looks good. Now we're going to put this away, and we want to get a look in there, see if we could see down on that hose clamp, to see if we could see that clamp to push it back so we could see that air right there. Now we're going to have to go and fight with that. Once we could get that off, then we're going to have to remove this thermostat housing right here. Actually, this water inlet housing. And you'll notice on the bottom of that, there's a gasket. You're going to see it's leaking from down here. See that gasket where those 2 bolts are? That's leaking, so that has to get removed. What's being done here now is I'm using this prime bar on the side with the angle, bracing it against here, and using the point against the clamp that will be on the ear of the clamp to walk it around so I could get the 2 ear in the front where I could get the pliers on it to clamp it, to move it up on the hose for detaching the hose when this outlet inlet spout is removed by the two bolts. Once the clamp has reached that position where we could see those two here, I want to take the box end of a wrench and place it on the last ear, pulling on the wrench, forcing that clamp to slide on the hose so it could position itself to the front here. Now, in order for this clamp to slide, you're going to have to spray some lubricant or put some oil on the hose, so when movement occur with the clamp, the oil will seep between its mating surface on the interior, allowing it to slip for movement of the clamp. That is the ideal position for the hose clamp now that it can be removed. The best tool for doing so is this 14mm combination wrench box end. You might need to file it down to get it in between these bolts in the back here and the ear of the clamp. This is when you want to remove the antifreeze from the radiator, and with the drain plug release, it's just going to drip on the bottom. So when you take this one off, it's going to be very difficult. It's going to require both hands. What I want to show you is you want to first remove this drain plug. You don't want to remove the cap because everything's going to come slushing down on you below. So by removing this first, you come here and you remove the cap and listen what happens below. All the coolant is flowing into the catch can. So that's the way for releasing the coolant from a radiator. You never take the cap off first. You always go below and remove the drain plug when the radiator is absolutely cold. Then you come up top here and you remove the cap, and spill proof. Once that antifreeze coolant has been collected in the container, you want to immediately place it back into its original container with a funnel, using a cloth for filtering it. Any sand or grain that may remain inside will be eliminated. Comes time for pouring that antifreeze into these containers. You can see all the solids we have collected. You're going to want to use a little bowl like this. You don't want to pick that container up and try to lean it over that funnel. It's going to cause a spill. So that's the benefit of using the white shirt, so we could see the contaminant that was in the antifreeze. Removal of that water inlet. Down there is the outlet. Going to have to take this clamp off. Going to have to remove these distributor wire from that hole down right there. The ECU coolant temperature sensor and the gauge coolant temperature sensor. You want to be careful with this gauge temperature sensor connection. This terminal here sometimes could play on the sensor because it's like riveted to the sensor. So if you have that play in the future, you're going to have a gauge that's fluctuating, the temperature gauge, and that will be most likely because of the connection of the terminal with the plug and the sensor. Now when replacing this, again, we want to remember we should clean it out and apply some dielectric grease. Replacing this part and removing it looks difficult because you would think you have to remove this timing cover, but that's not possible, and if it is so, it will most likely be difficult. What we want to do is we want to get those two 13mm bolts out that you see there, and we're going to use the same tool that we use for removing the distributor. It's very essential and important that you use a 13mm 6-point short socket with a 3/8 drive extension for getting in there and making that connection and turning this outlet off. Once these clamps are removed, you don't want to leave them on the hose like back here so you don't lose them. That's what most mechanics will do. You want to completely remove them and have them in a state like this, so this way the spring could reset itself for when the torsion clamp is to be installed. It will clamp with a maximum sealing ability against the neck, and this is important when the engine gets hot What's important about this clamp is that it prevents the hose from bursting. With this clamp equipped onto the cooling system, in the event the cooling system should get extremely hot and overheat, this clamp, the pressure from inside the hose, will cause it to expand and blow the pressure out from between the hose and the spout instead of breaking the hose. Comparing to using a worm clamp, if this hose should get overheat and expand, it will burst because it has no way for releasing itself or releasing the pressure where the worm clamp is torqued down. This clamp is a spring tension, and that tension can be released when pressure is applied on its ear or within its mating surface. I hope you understand what I'm trying to say. This prevents the hose from bursting and becoming damaged. Another thing is that the hose on this vehicle currently are 20 years old, and they are original Nissan hose. As you can see, the part number is still equipped on it. Compared to factory hose, these are the best because they're most likely silicone hose, these factory hose. If you're to compare these hose to the aftermarket will most likely have a rubber hose which will deteriorate and rot faster than these factory Nissan silicone hose, which is approximately 20 years old. You see right behind that clamp there, you can see a little Nissan sign. That bolt is going to become very difficult to remove. As you can see, was successful at removing this one. Since it's involved next to the water jacket, it will most likely become corrosive and snap off in there. So when you're releasing the bolt, when you untighten it, try to turn it back in and untighten it again, slowly releasing. You should get the idea. And what this will be able to do is to break up the rust on the threads. You want to also make sure you use some of this CRC power lube, which is going to be able to prevent that bolt from breaking. If that bolt breaks, it means you have to remove that intake manifold, the lower manifold, and those videos are in the video description. But you do not want to do that. You just want to slide this inlet spout off the lower intake manifold and replace its gasket with its fasteners. When you're going to be doing this removal, you will need this tool set up exactly. So one hand could hold on the extension bar onto the nut, making sure that it does not slip off the bolt, while the other hand turns the ratchet handle. You should be able to see down in that area, but what I want to let you know is where this manifold meets the cylinder head. You will also have a leak in the future because that's a metal shim gasket that used down in the bottom there, that joint. Best thing is, when you're doing this, is you want to do a complete gasket service kit. You want to replace all the coolant gasket for the intake manifold and the thermostat housing, preventing any future repairs. You will know when your fixture is coming apart because you're going to see it starting to get loose. You'll be able to shake it with your hands. You just have to be careful with that bolt. Make sure that it does not snap inside of its hole. When you take a look at that bolt, we can see it's all the way out. But what's happening is the aluminum and the steel bolt is corroded together, and the casting is what's holding it back together, the corrosion. The threads are already released from the inside. You have to be careful with these fittings. And these fasteners, you have to use a lot of fastener penetrating oil on them. Let them soak. This is aluminum. It's very fragile stuff. When you're working with it, you want to stay away from power tools, because when you put a power tool on that and you just wing it out, you might end up pulling out all the threads on the steel bolt, and that's going to damage the aluminum casting. So you have to do this with hand, care, and lubricating oil. Kind of sound like a doctor, but that's not what it's about. You also got to watch out for busting your knuckles. This is why you need some good gloves, not just plastic. You want to get some cloth gloves on your hand so it could buff them in the event you should slip, hit your hands anywhere. Here's another strategy for removing that difficult bolt that's going to remain stuck inside of the casting of the aluminum. You have to turn with a ratchet, then you have to use these pliers to grab the back of the bolt so you can pull it forward while you're screwing it with this ratchet to walk it out. What's happening here is not the thread is damaged. What's happening here is the corrosion that built up in this sleeve area is holding back the thread from walking out of the hole. So we have to assist the bolt by applying pressure, pushing it back, turning it so the threads could eat away at the corrosion while using the penetrating lube for removing it. It's been over an hour and almost a day we've been trying to remove this bolt, preventing it from becoming damaged. Removing this part will not be easy, and it's something that should be done by a professional mechanic. As you can see around the neck of the spout, all of the garbage that's causing that leak between the hose and the outlet. So this is going to take a lot of fighting, not so much mechanic. So if you don't like fighting, don't try to attempt to do this. You're most likely going to break your fingers and go blind. The most important part in this removal is making sure you get this 8mm bolt out of the way that holds this timing cover to the housing itself. Without that bolt removed, you will not be able to remove the housing. Let's close out this video because it's nearly impossible to remove this inlet outlet spout from the engine because of the clamp that's on the hose. It's jamming against the injector rail. Even though we removed #1 spark plug boot to slide this over, it's impossible to remove this fixture with this rubber hose attached to it. And that bolt still frozen, corroded into it. Very, very difficult. I do not recommend that you take on this task. I do recommend that you remove that intake planium, injector rail, and the lower planium, and then try to do this. Never try this. Do not do this inside of the vehicle. You will hurt your back. You will hurt your hand. You will become angry. Don't do it. Thank you for watching this video, and see you in the next video where we're going to have this removed for you. But don't attempt to do this. Never. Let's take a look at underside of the throttle body upper intake planium. So what we have here are the two pipes for coolant to circulate, and we can see that goes to the EGR valve, and it comes out from the EGR valve here. It goes down here, goes into the throttle body, comes out the throttle body, and it goes back to the hose that goes down to the engine pipe where we have the bypass. This other tube here, that's for the PCV, and that makes this connection straight to the PCV. So we can see we have two vacuum hoses here, and they're not necessary for disconnecting when removing the planium. You only need to disconnect this one, which goes to the fuel pressure regulator. We have two plugs for the idle air control valve and the idle air control valve motor. You will also need to disconnect this vacuum line that goes to the EGR solenoid. So that's about it. This is the thermos, cold start thermos. This will need to fast idle. So this is how we will have to remove this tube for the coolant. But we also need this one here, which is attached to the coolant. So it will have to be separated if the line should be deleted from underneath the intake planium. This one here is also attached. So they're all attached together And the one that you will need is this one here that goes to the PCV valve. Not so much these two, but these pipes are still connected to the engine. Most likely what you see on that thermostat housing is happening in here and all of the ends of the pipes. So most likely you're going to want to investigate this area, making sure this hose is not ready for leaking. Most likely it will not. It will leak at the end here, like we have seen on the engine. So this is also known as an acoustic intake manifold because of its long tube runners. They're all equal for tuning the air to the intake valve and the cylinder. So a equal amount of measurement in airflow is sent to the cylinder for even combustion, and it also helps prevent misfire. Here you will notice is an adjuster screw for the engine idle. It should be never tampered with. Like you see here, it has been tampered with. That should never be messed with because that's set at factory. If you have problem with the engine idle, most likely the throttle body in there will need cleaning, or maybe you have a vacuum leak or some other fuel pressure issue. PCV also could be an issue that affects idle. So those are the things you're going to want to consult. At the top of the intake manifold in there, you will notice that's the Egr temperature sensor. This is the plug for it. Also, you have the air bleeder screw for bleeding the coolant. This is where the highest point of the cooling system is, and most of the air will end up here before it goes to the radiator. So by opening this screw and allow the coolant to flow, the air will empty itself out from here. Then you will lock the screw, and that will help prevent overheating for the engine. If this coolant bypass for the throttle body has been deleted, which means these two are like what you see here, and on the engine side it just makes a U-turn. You will not need to bleed from this screw, obviously, and the engine will most likely not experience overheat from air bubbles entering it, because those air bubbles will fastly move to the radiator cap, which is the highest point on the engine cooling circuit. That is what the throttle body Egr coolant bypass look like on the engine. It's simply just attaching those two hoses together to recirculate the hose. You don't want to put a plug at the end of the hose because this is going to prevent circulation inside the block. The next thing you need to take a look at is that fuel pressure regulator and its vacuum spout. Most likely will develop corrosion and affect vacuum and the operation of the fuel pressure regulator. Should the fuel pressure regulator fail, it will most likely detect a DTC code P0327 or 30228, also oxygen sensor code. Now we have the inlet, or I should say outlet pipe for the coolant system fixed and reinstalled. In our next video we're going to take a look at doing this, but what you should really do is remove this complete intake manifold for servicing the gasket on that outlet. It's now time for removing these paper towel, cleaning the surface of the intake manifold, removing the silicone, applying a new coat, and install its shim gasket with the upper planium, making all the necessary connections for startup and testing of the engine. You are going to be cleaning the surface of the intake planium and the manifold first sealer in its gasket, you want to use a blade like this, and you want to push everything away from the inside of the port. If anything should fall in, you will have to use some air to blow it out. You don't want it to fall in the engine, because then you'll have problems. So you will leave that paper in there, do your cleaning first, and then pull the paper out, bringing all the waste with it. This is a gasket shim that was removed from between the intake manifold and the upper planning. Most of the time, this gasket joint will need to be replaced with a genuine Nissan dealer part. In our current condition, this gasket needs to be transformed from the current state it's in by using a heavy grit sandpaper for sanding the surface, removing the rust, creating that groove for holding and embedding that paint that will be required for preventing rust. With both sides of the shim gasket prepare for painting, we want to make sure we retain most of that black paint around the port area. If it's not there, then you're going to have to take a chance with silicone at sealing this shim against its mating surface. This is the idea that you want to achieve with that old gasket. Painting it, it's going to prevent the shim, the metal, from rusting like you've seen on all the other parts, and it also will restore the seal with a thin coat of silicone on both sides. You don't want too much so it block the inside of the passageway. So in the video description, you're going to see how to replace and remove the upper intake planium for this engine. You need to go and take a look at that.